Alright, here's a video on the 3 G's for cellular respiration: glucose, glycogen, and glucagon. And glucose, we'll just give a brief summary right now. Glucose is the primary sugar in the body. So let's write that down. Find my pen. So glucose over here is a sugar. It's the primary sugar. It's the sugar the body prefers. And it's used to make adenosine triphosphate. I'll put it over here. The energy that we need, ATP. And glycogen is stored glucose. So if there's extra glucose in the blood, it's stored as glycogen in the liver. So we'll say stored glucose for now. Just giving a recap. Well, not a recap, we just started, but just a preview here. And glucagon is a hormone, and glucagon will tell glycogen, well, will tell the liver to convert glycogen back into glucose. So those are the 3 G's in cellular respiration. So let's get down to it. Let's get a clean page. So we have glucose, if we can get a pen working. We'll use red and green. So we know we have glucose, a monosaccharide. It's a simple sugar. The body prefers glucose over any other sugar. So when you eat food, the body will break down that food, whatever you're eating, into glucose in the small intestine. So glucose is broken down in food in the small intestines. Now, from the small intestines, glucose will enter the bloodstream, and once in the bloodstream, the pancreas will release insulin, and insulin will attach itself to all of your cells, and glucose will enter your cells. And from there is a series of steps that will make ATP. So some foods have glucose in there already, like grains. So we think about the foods that have glucose, the foods that already have glucose in them, like grains, bread and rice and fruits and vegetables and honey and so forth. So those foods already have glucose in them. But if foods do not have glucose, the body will convert that glucose. So for example, like fruits. Fruits have glucose and fructose in it, but they'll take the fructose, and it'll be converted into glucose. And also, other sugars, like galactose, for example, which is found in dairy. Galactose will be converted into glucose also. And even if you're having foods that have no sugars in them, like meats, even meat will be converted eventually into glucose. But the body prefers glucose. So if we take the proteins in meat, then proteins will be broken down into amino acids, and the amino acids will then enter the liver and made into glucose. So if it has to be converted into glucose, the first pathway is to get into the liver. So let's clear that out. Here's my clear. There we go, clear it all out. So once glucose is released into the blood, the pancreas will release insulin. And I'm simplifying it here, but there are beta cells. Beta cells, I'll put down the beta cells in the pancreas. Beta cells in the pancreas will release the hormone, the chemical messenger, insulin. And what insulin will do is we'll just make a cell here, pretend that's a cell. Insulin, we'll put insulin, let's say, make it yellow. No, we'll make it blue. So let's say that's insulin over here. So when insulin attaches itself to the cell, and we'll have, let's say, this color of all the glucose coming into the cell. And of course, there's a lot of processes that happen here. But that's how glucose will enter the cell through insulin. And it will enter your 37 trillion cells you have in your body. So that's the G, the first G of glucose. Now, any extra glucose will return back to the liver and be converted. And by the way, that insulin, that once it's done its job, it will return back to the liver and be recycled into other things. So insulin did its job, it's done, and it will go back to the liver. Everything ends up in the liver. So the next G is glycogen, which we said earlier. Glycogen. And now this extra glucose will be stored as glycogen in the liver. Now they're storing it as glycogen because of this fancy term, and I'll write it down. Osmotic pressure. You don't want the liver just storing glucose, because glucose will increase osmotic pressure, and when that happens, in other words, just water is being drawn into the blood, and that can cause dangerous swelling. So they store it as glycogen because it will release that osmotic pressure. That's all it is. So for example, let's say your last meal was at 5 p.m. You had your glucose and the energy your body needs. And now anything else your body needs throughout the night, let's say you didn't eat, they'll just convert glycogen into glucose throughout the night. Now if, let's say you go to sleep and you wake up, you don't have breakfast, your glycogen levels are lower in the morning if you slept for 8 hours, for example, and you didn't eat since 5 o'clock the previous night. So when your glycogen levels are low, that's when the other G that we talked about in this video kicks in. So let's clear this again. Clear it all. There we go. So we had our first G of glucose, the sugar, so we can make ATP. Any extra glucose will be stored as, guess what? What was it? You got it. Glycogen. Stored in the liver. And then if glycogen levels are low, then the pancreas is going to secrete another hormone, which we talked about, and this is going to be glucagon. Now, with glycogen, with glucose, I mean, we had, when glucose entered the blood, we had beta cells in the pancreas releasing insulin. So in the pancreas, to release glucagon, another hormone, we'll have alpha cells. They'll release glucagon. And what glucagon does is very simple. It's going to signal the liver to release glycogen, to convert glycogen into glucose. Okay, so by the way, there's another hormone. It's called adrenaline. I'm sure you're familiar with that term. So adrenaline can also be used to initiate glycogen to make glucose, also in times of severe stress, or stress, like your body kicks in the fight or flight response. It's also called, adrenaline, by the way, is epinephrine. So I'll put what that is. But for in everyday use, we're using glucagon. But if you're in severe stress, adrenaline definitely could be released. So those are the 3 G's. Glucose, the sugar needed to make adenosine triphosphate, ATP, in cellular respiration. Glycogen is stored glucose in the liver to use it in case we have no glucose or no sugar in the blood. And glucagon is to signal the liver to make glycogen make glucose. Simple as that. Those are the 3 G's.